All right. So how much money should be deposited in an account today that earns 9% monthly so that it will accumulate to 10,000 in 3 years? So we did stuff like this last time, but let's go ahead and do this anyway. So again, let me just rewrite that formula we had a second ago. So P1 plus R over N to the NT. So what I want is $10,000. I'm getting a 9% interest rate. I'm compounding it monthly, so what's my N?
12.
Yeah, 12 times a year. And I'm going to do this for 3 years. So this guy right here, this is just some number. I can punch it into a calculator to see what it is. Yeah, that's 12 times 3. Right? So I'm just going to punch that number into a calculator and then divide 10,000 by it. That'll give me what I need to put in now. Right? So let's do that. Actually, since we're going to be using Excel later, let me go ahead and pull up Excel. So we've got 1 plus 0.09 over 12 to the, well, 12 times 3, let me just do that, it's 36. All right, and then the other side was 10,000, so 10,000 divided by that. So I need to put $7,600 and change if I want to get 10,000 in 3 years. What are interest rates like right now? I mean, that 9%, is that?
They're like 3% right now, 9% is like unbelievable.
Yeah, except 3% is what you pay if you borrow money. What you get if you save money right now is about 0.5%. So it's right now the interest rate is less than the inflation rate. So if you have money in the bank, you're really actually losing. But okay. All right. On that happy note, let's keep going. All right. Passbook savings account has a rate of 4%. Find the effective annual yield if the interest is compounded monthly. Okay, so that's actually kind of like what we just did. We haven't actually talked about effective annual yield, but it's exactly what it sounds like. It's like if I took that 4% month compounded monthly and turned it into some percent yearly, what would that percent be is what we're looking for. And this is useful for, like, I mean, if Bain gives you several options, like one's monthly, one's continuously, one's yearly, changing everything to yearly kind of makes it where you can compare, see which one's better. So, but to actually do it, it's really easy. You just say, okay, well, if I did 4 monthly, I would be going to, in 1 year, 12 times 1. And that would be what I multiply my principal by for 1 year, right? So I'm just going to see what that is. It'll be 1 point something. 1 point something. Whatever this point something is, that's the annual interest rate. So grab my calculator again. So 1 plus 0.04 over 12, except I can't type. No. 104 over 12 to the 12. So if I was just doing this as a annual interest rate, it'd be 4.07 interest instead of just 4.
4.07.
Yeah, 4.0742 or whatever. The nearest tenths would be 4.1. All right. Okay, so again, this is what this is used for. So if the guy offers you, hey, I'll give you 7.5% monthly or 7.75% annually, you know which one to take. So the effective annual yield for the 7.5 monthly, again, same thing. We just pretend like we're doing 1 year. So 1 plus 0.075 per month for 12 months. That'd be the same thing as if you gave me 7.76 for a year. So 2 decimal places. Yep. So 7.76. So is that better than 7? Well, okay, this one is kind of, what color is a white horse? I mean, they already gave us, hey, it's compounded annually, right? So what's the effective annual? What? Oh, it's, yeah, 7.75. So which one is better? Yeah, the 7.5 monthly is a little bit better. Okay, that's more of the same thing. I don't think we've gotten to the credit card stuff yet. No, that's not very hard. Oh, that's more of the same thing. Do you want to go over that? No. I mean, I'm here for y'all, so it's like, if y'all want to talk about it, we can. But this is the same thing. So it's like, how much would you earn the first? How much more would you earn for the first investment than the second investment? So both of these are just straight plug into our formula. I mean, they give us the principal, the rate, the N, and the T. So we're just finding both of them routes and then subtracting them. Let's do that real quick. So for the first guy, for the first guy, you've got principal is 27,000, and 1 plus the rate. So what's the rate? 10%, so 0.1. Compounded annually, so I don't really have to divide by anything. But, and then to the 30 years, so again, annual is 1 times 30 is 30. Yeah, I thought that's exactly what I thought, but okay. So the first one, you would wind up with $471,000. The other one, same thing, 27,000. 1 plus 0.05 now, still divided by 1, so I'm going to leave it out. The 30. Second one, you would earn $116,000. And so how much more would you earn? $341,000. And it does say round to the nearest dollar. So, on a random side note, is that surprising that you put 27,000 in and got 471,000 out?
Seems like a lot, but nobody gets 10% interest.
Yeah, nobody gets 10% interest, and I mean the 10% interest is a big deal, but the other big deal is, I mean, you have to leave it in there for 30 years. So that's once upon a time, somebody was interviewing Albert Einstein, and they asked him, "Hey, what's the most powerful force in the universe?" And they thought, well, he would either say something from physics because he's Einstein, or he might like wax philosophical and say love or something like that. Compound interest. It's like, if you give it enough time, it turns, well, yeah, it's pretty ridiculous what can happen with compound interest. Yeah.
One of these questions that I did with someone does for like $19,000 in 30 years and he's like over $1 million. And I'm like,
That's really the way it works. I mean, that's all right. So this is the same thing except for a two-step. It starts at 7% for 5 years, and then it goes up to 7.28%. And it wants to know what will be the value after 10 years. All right, so we're going to do the same thing. We're just going to take the first 5 years by itself. What should I do to find how much he has at the end of the first 5 years? 4,000.
7 and 0.07.
Okay, what do I put before the 0.07? Yeah, I always start off 1 plus and then 0.07. Do I divide it by anything? 2, because it's semi-annual, so twice a year. And then what do I raise it to?
5 years.
Right, so we're going for 5 years and we're going twice a year. So, whoops, I need the next. Yeah. So at the end of the first 5 years, he's up to $5,600. And now we're going to start there. So we're going to say, okay, that's our new principal. And then 1 plus, what do I put for my rate now? 728. And it's still, no, now it's quarterly. So divide by 4. And I'm going for 5 more years. So 5 more years, 4 times a year, 20. So he's going to wind up with a little over $8,000. There's a dollar. I'm still not finding the credit card stuff. Maybe that's in homework 6. I thought it was in homework 5. This is the same. Okay, let's do one more of these and then we'll jump to homework 6 then. So you would like to have $74,000 in 15 years. I would like to have $74,000 in 15 years. Account A has 9.5 once a year. B has 9% daily. How much will you have to deposit in each one to reach your goal? Assume 360 days in a year, which is what banks do. They go 360 instead of 365. All right, so this is just like that first problem we did today. This time we know the amount. So the amount is 74,000. Right? Yeah, 74,000. So that's going to be P1 plus R over N to the NT. So we're looking for the P. So we're going to plug in, get what that number is, and then divide into 74,000 for both cases. Right? All right, so for A, so 1 plus, we're doing 9.5% interest once a year, so we don't even have to divide it by anything. And we're going for 15 years. And equals 74,000 divided by that. So now I would have to have a little over 18 to put in. For B, same thing, 1 plus 0.09 daily, so divided by 360. And to whatever 360 times 15 is. Actually, I'm doing the exact same thing I was doing before, so I can't just drag it. So for B, I would have to have a little over 19,000. Round up to the nearest dollar. And round up to, whoops, no, that is right. Nearest dollar. Okay. So is everybody pretty happy with compound interest at this point? All right. Bless you. Let's go on to 6. Oh, no, I don't want number 5. It's just there. More 6. Okay. Before we get started, let me tell you just kind of real quick what this is going to be about. So if you try to view an example, well, just like on several of these things, I'm telling you how to do these things on Excel. It's a whole lot easier than doing them by hand. So if you look at the view an example, it's going to be horrible. But there's 3 functions in Excel that basically will do this whole thing for you. So there's, I think all we use in here is FV, which is future value. This is of an annuity. What is an annuity? Anybody know? An annuity is it's like a retirement plan. You put money in every month or every year or whatever. And it's like compound interest, except compound interest, you're just putting in money at the beginning, wait until the end, pulling it out. An annuity is like, no, you make a payment every month or something. So the money you put in at the beginning gets compounded the whole time. Your next one gets compounded almost the whole time. So you just keep adding to it. Okay. So this is, if you know kind of what you're putting into an annuity and you want to know, hey, how much is it going to be worth 30 years from now? There's PPMT as the other investment one. This is if you want the prepayment is what it stands for. But basically this is if you know what you want your annuity to be, and this tells you what payments will get you there. All right. So I think those are the only 2 we're actually going to use in investments. I don't think we need present value, but I might be wrong. Well, let me put it down just in case. I don't think we do it in this class, but PV is present value. This is like, it's kind of hard to describe. It's like, okay, if I give you, say you win the lottery, and I'll be like, all right, I'll pay you $1 million over the course of the next 15 years. And well, $1 million over the course of the next 15 years is worth less to you than $1 million today, because $1 million today you could turn around investment and whatnot. So present value is like, if you've got something like that, what would be the equivalent lump sum amount of money right now? If that one does. All right. I don't think we do that in this class, so I have to remember. All right. And then the other one is, well, it's called amortization, but this is basically like your mortgages and stuff. And there's only one function we're going to use on that, which is payment. And that's pretty self-explanatory. I tell you everything about the mortgage. What are your monthly payments going to be? It spits it out. Right? Okay. So again, if you do these by hand or by view an example, it's going to be hard. But if you just remember these 3 or maybe those 4 guys, Excel will do this whole thing for you. So, all right. So let's go in here. So they give you the formula. You can see what the formula looks like. It's ugly. So we're not going to use the formula. We're going to use Excel. How much should you deposit at the end of each month into an investment that pays 7% monthly to have $4 million when you retire in 36 years? How much of that $4 million comes from interest? Use one of the formulas below. All right. So this time we know what our goal is, right? We're looking for what we pay in. So we're going to use the PPMT because, again, we know what we want to wind up with. We need to know what payments will get us there. All right. So, and these things have a lot of arguments in them. So I'm going to, I don't know if you can read that. It says rate, per, in per, PV, TV, and type. That's a lot of stuff. But if you click on the little insert function thing, it'll give you a little box that makes it maybe a little bit easier to figure out. wish I could make that box bigger. Y'all can't see what the box says very well, can you? Okay, I'm not seeing a way to put it in there. Okay, so on rate, it says the interest rate per period, right? Which, you know, they always give you the interest rate in years, but when you're actually using this thing in Excel, you want the interest rate per period. So it's 7% monthly, so it's 7% per month. So I put 0.07 divided by 12 in there, right? Okay. Per, it says, specifies the period. Okay, that's always just going to be a 1. That's just where we're starting. Okay, in per is the total number of periods we're doing this for. So we're going for 36 years, and we're doing 12 periods every time. So I put in 36 times 12. Okay. And then the present value is, oops, oh, I shouldn't have typed equals. Well, that 36 times 12. Actually, I think it's the, I'll put it in one of them, see if it works. Let's put in 4 million. Okay, yeah, that does it. So if I want to get that, I have to make $2,057 payments. So that's it. And paste, and first I want to round up, so that. I also don't want the dollar sign or the parentheses in there. Cool. I went black. Okay. All right. Yeah, so the only thing left was actually to type the 2058 into there, but it's like, okay. So now here's the kicker. Out of that out of the $4 million that we get when 36 years from now, how much of that is what we put in? How much did we get in interest? So how do you think we're going to figure that? There is no Excel trick for it. This is just you thinking about what we're doing.
Yes. For 36 years, 36 times 12 months.
36 times 12 times
the 2058 thing.
So we're putting in less than $900,000, and then 4 million minus that. So we got 3 million some odd dollars in interest. That's pretty awesome, ain't it? Of course, again, you're going to be hard pressed to find 7% nowadays, but it just kind of goes to show you over the course of 36 years what can happen with compound interest. So let's do another one. Okay. The value of an annuity is all the deposits plus all the interest paid. Okay, that was silly. All right, I was wanting to do more problems, but okay. Y'all know what stocks and bonds are? What's a stock or a bond? Pick one and tell me about it.
Stock is whenever you buy like a share, like a actual percentage, a small piece of the company. You can buy that and you own that piece of the company. You can later on, if the company's value increases, your share in turn will increase and you can make money that way. They also companies pay dividends to shareholders for a small piece of their profits or whatever.
Yeah, which let me say one thing about that while we're at it. Used to, the reason to own stocks was for dividends. It's like when you buy into a company, hey, every time they make money, they pay you a little bit. That was the value of it. In the current generation where the Fed has been printing money left and right, whatever, it's gotten to where no one actually cares about the dividends anymore. It's like you don't buy stocks because you believe the company is going to make money. You buy stocks because you're kind of gambling that the stock goes up. So, I mean, you don't buy a stock and hold it for 5 years anymore, which used to be the model. I mean, now it's, oh, you might have a stock for a week because you think, okay, this is going to really go up this week, which, anyway, that's my random tirade while I'm at it. Okay, so that's stocks. And then bonds.
Bonds are like federally insured bond or whatever. They basically buy bonds from the government. Government agrees to pay you a certain amount back whenever the bond matures, but it has like a time limit on them. Some of them are years, some of them are 10 years, some of them are 20 years.
So it's like, I mean, for example, you could buy $100 bond now that matures 5 years from now. And because it matures 5 years from now, the government only charges you like $90 to buy it or something. So it's, but
and then hold it past the time it matures to appreciate.
Right. Bonds are commitment to pay the, that's how it was purchased. Yeah, with interest.
Bonds are lower risk.
Yeah, bonds are lower risk than stocks. I need to find that. Bonds are lower risk, but not sharing ownership. Yeah, the first one, I guess. So let's try again. I don't want to try again. We got it right the first time. Okay. So now we're back to doing annuities, which is more what I wanted to do. So if you deposit $3,000 a year, 3.5% interest, which is still a little high, but I mean you could find, can't get this from a bank, but you might be able to find investments or something that would give you that. And for 10 years, how much money will you have? All right, so are we going to use the PPMT that we used last time, or are we going to use the FV? Yeah, we know the payments we want. We want to find, hey, what's this thing going to be worth out in the future? So we go future value. And again, since I don't remember all the little whatevers, I'm going to click the F of X and it'll tell me what to put in. So I put in the rate, and again, it's rate per period. But since we're doing this annually, we don't have to worry about the per period part. So the rate's 0.35. Number of periods, well, it'd be 10 times however many we do per year, but we're doing this annually, so just 10. And our payment each time is $3,000, and that's all we need. So it actually gave us a negative, but that's because we really should have put in negative 3,000 because it was a payment. But okay. Round to the nearest dollar. So this is going to be worth $35,000. And y'all should be able to do this math. How much should we actually pay in ourselves? Yeah, we paid $3,000 a year for 10 years is 30. So that means the other $51.94 is our interest. All right. So same thing. Future value. We're getting 0.065 for our rate. We're doing this for 25 years, and we're paying $5,000. So make $294,000. How would we figure out the interest?
Multiply 5,000 times 25 and subtract
Yeah, so we paid in 5,000 every year for 25 years. So we paid in 125,000 of that. And then, so if I go 294, 438 minus that, we made 169 in interest. Let's go to that side. Okay, what's different about this one compared to the last couple of them?
It's monthly payment.
Yeah, we're doing monthly, so that's going to change two things. When we put in our rate, we're going to go 0.06 divided by 12. And then when we put in our number of payments, we're going to put 40 times 12 because we're doing this every month. All right. So future value, our rate is 0.06 divided by 12. Number of periods, 40 years times 12. And we're putting in $20 a month. Actually, let me go ahead and put in -20, which you're really supposed to do because it's a payment, it should be negative. So we're going to wind up with nearly $40,000 at the end of the 40 years. Now it's the nearest dollar. It's going to become 30. And the interest, well, again, all we need to do is figure out what did we actually pay in. What did we pay in?
$40 a year for 40 years.
Yeah, we did, well, $20 a month, 40 years, 12 months a year. So we put in $9,600. So that minus. So we got about $30,000 in interest for our troubles. You like that, Austin?
Yeah.
Put in 10,000, get out 40. But it takes 40 years to do it. So I guess the moral of the story, this is why y'all should start saving for retirement now when you have 40 years to do this. It's like, okay. Okay. 3,000 at the end of every 3 months. And then found the. So this is actually the exact same thing. They just worded it different, but sure, we'll do one more. And we'll see if we can find something else. So future value, we've got 3,000 at the, whoops. Do this. Okay, so the rate is 0.0625. Do I need to divide it by anything? Yeah, divide it by 4 because I'm doing this quarterly. And then number of periods, 3 times 4, because I'm in 3 years and then I'm doing 4 every year. And then my payment each time, $3,000. Actually, it's a payment, so we'll put in negative $3,000 like I'm supposed to. So I'll have $39,000. Round up to 1. All right. And to find out how much of that was interest, I just need to figure out what I paid. So $3,000 per time, 4 times a year for 3 years. I paid $36,000. Round up to $39,000. Not bad, but that's because I only had 3 years working for me. Not bad, not great either. Okay, that's the same thing. But let's try it. Do the words scare you? Or you're not scared of no words, are you, Austin? Okay. So you earned a bachelor's degree. Now you're teaching high school. The district offers teachers an opportunity to take a year off and earn a master's degree. To achieve this goal, you deposit $4,000 at the end of each year. in an annuity that pays 7% annually, how much will you have saved at the end of 5 years? Find the interest. All right, so same thing again. Actually, this reminds me, I didn't do something when we were doing compound interest that I always do. Let me stop and do that real quick. But okay, the rate is 0.07. We're doing this annually, so we don't divide by anything. We're doing this for 5 years. Our payment each time is $4,000. That's all we really need. So 23. Okay, fine. So we will have made $23,000. How much is interest? Well, if I put in $4,000 a year for 5 years, that's 20. So the other 3,003 is all interest. Okay. All right. Before we keep going, let's actually stop and talk about something that is part of most of y'all's lives right now. Y'all know the difference between a subsidized and an unsubsidized student loan? What's the difference between unsubsidized and subsidized student loan?
Unsubsidized starts collecting interest from the day you take the loan. Subsidized doesn't start collecting interest until you finish going to school for 6 months.
Right. So let's pretend for a second like you do that. How many? I don't know. Clarendon's pretty cheap. Most 4-year, pretend like we're going to a 4-year school for a second. Most 4-year schools are at least 15,000 or something. So let's say that we do, we're taking out 15,000 every year. Oops. Student loans are actually the only interest rate that isn't very good right now. They're about maybe 6% or something. And we're going to go to school for 4 years. So 4 times 12. And we'll say we're taking out 15,000 a year. So that would be, what's 15 divided by 12? About 1250 or something. I'm just kind of making something up, but that's okay. All right. So if it's an unsubsidized loan so that we're paying interest on it as we go. When we get out of here, yeah, it's actually not too bad. We're going to owe an extra $7,000. Whereas if it was a subsidized loan, then, I mean, we borrowed 15 a year for 4 years, so we owe 60. What does that do in terms of the long run? How long do you want to take to pay this? You're going to make the minimum payments and take 10 years to pay them off. That's one thing Obama was really big on. It's like, we don't need to burden our people with student loans so bad. Instead of making them pay them off in 10 years, we should give them 15 or 20 years to pay them off. Is that what you want to do? Let's go back to this guy. So this is actually the one we haven't done yet. So it's just like a mortgage. So we want to know the payment. So if we take this $67,000 and we'll say it's still doing 6% interest. Actually, I should not put that in first. First thing goes in is the rate. So 6% divided by 12. Number of periods is 12 times 10 years if we're going to take 10 years to pay it off. And then 67,622. So we're going to be making $750 payments. How much are we paying all together? Well, we're making $750 payments for 10 years and every month. So we're paying $90,000 for the $60,000 we had when we were in school. Does that seem like a lot, or does that Maybe.
It's not a little.
It's not a little. How about, let's go with, say Obama gets his way and he gives us 20 years to pay off this. So let's still go 6% divided by 12. 12 times 20. Oops. 12 times 20. And 67,622. Hey, now, thanks to the grace of the government, we only have to pay like $500 a month instead of $750. And then if we times that by 20 years, now we're paying them back $116,000. Yeah. I mean, that's nearly, I mean, or again, as far as physical dollars, we got $60,000.
Government doubles the profit.
Yeah. I mean, it's like, well, I mean, the 10-year plan, I mean, we borrowed 60, paid back 90, so they got like 50% profit. Now they're getting almost 100% profit. So that's student loans. Actually, while we're at it, let's talk about mortgages. So again, we'll do this a little bit later in the thing, but how much you want to pay for a house? What do you want to pay for a house? How much do you think you're going to pay for a house someday? 200,000. Okay. Most house loans now are pretty good. For a 30-year loan, you're probably going to get about 4.5%. Well, maybe let's make it 4.9. So 12. You're going to be paying these 12 times a year for 30 years, and you're going to buy yourself a $200,000 home. So, oh, that's not right. What did I do wrong? Oh, I put in 4.9. That would be if you're paying 490% interest. If you're doing 4.9% interest, you're going to be paying $1,000 a month, roughly. So over the course of 30 years, 12 times 30 times that. You're going to pay nearly double the cost of the house. And that's with good interest rates that we have now. All right. What if you're going to do the same house, but let's buy it in 15 years this time? So we've got one difference is if you do a 15-year loan, instead of getting that 4.9, you're probably going to get more like 3.9. But let's even say, pretend it was the same interest rate. So 4.9 divided by 12. 12 times 15. $200,000. Now you're going to have to pay $1,500 a month. But if you look in the long run, yeah, you're saving yourself $100,000. Can't do that. Let's go back to the 30 years for a second. Out of that $1,000, how much do you think actually goes towards the value of the house?
First, not very much of it.
At first, not very much of it. So I'm going to build something called a amortization schedule right quick, which this is something you should definitely do if you're going to take a really long-term loan, like 30 years or something. So let's put the principal, the interest, actually, let me call this one principal. So this is let's just say the amount of the loan. So the interest, principal, and the new amount. All right. So this is going to start out at a $200,000 house, right? Okay, the interest, well, we said the interest was 4.9. So the principal, well, it's everything we're paying that doesn't go to interest. So we decided we're making $1,061 house payments minus the interest. And so our new amount is our old amount minus whatever we applied to principal. And this one is the same as that one. Drag these down. Drag this down for 30 years. Let's try about there. We're not at 30. Whoa, that isn't doing what it should be doing. Okay. Okay, apparently this one isn't dragging down correctly. There we go. Still going. Okay, so apparently we've paid off the house at this point. So we paid it off about right there. All right. So let's look at what actually happens when we're paying off this house. So the whole time we're making $1,061 payments, right? What do you think about after we made our first $1,061 payment? Yeah, it barely changed. What about after the second $1,061 payment? So if you look at what's going to principal, I mean, we're making $1,060. 800 of that is going to interest. Let's see. Let's say, how long does it take us to get down $10,000? So this is 64. Actually, let's make one more column here. Say the month. So this is the first month. And just pull it down so we can see what's happening. Oh, that's not what I wanted to do. It's 1 plus that. All right, drag that one down. So sure enough, it takes us about 360 months. I guess we have a little bit, well, we came off $2 due to rounding error. So your last payment, they're probably going to charge you an extra $3. Okay, so to get from 200,000 down to 190, takes us 39 months, or 38 payments, I guess, is what we took us to get there. So 38 payments, so we paid basically $38,000, and we're paying a little more than that, so we're paying a little over $1,000 a month. So it took us $38,000 to take $10,000 off the top of the house.
What point, how many months does it take for half of the money we're paying in for about $530?
That's a good question. Yeah, so right about there. So 191 months, that's like 15 years. So, yeah, so anyway, the point on the front part, though, it's like, hey.
What happens on that schedule if you end up doing it and changed it and pays an extra $100 a month on the payment.
Okay, let's try that. See, so all we gotta do is come up here to the principal here. Instead of 1,061 minus, we're gonna go 1,161 minus. Oops, and we need to do that all the way down. Let's drag that down. All right. So now we're paying us. So first of all, you see it coming down a lot faster if we hit the 190 at 28 months instead of 38 months. We pay the thing off at 300 months. So 300 divided by 12 is 25. So 5 years, you can make an extra $100 a month. And as prophesied, if instead of an extra $100 a month, if you make an extra $500 a month, which is a lot, you pay it off in 15. But actually, I do want to do that. So I want you to see how much faster it comes off the. Sure enough, around 180 or so, we should pay it off. Yeah. So we paid it off in 15 years. And kind of the thing I want you to see as far as how it works along the way, on that 30-year loan, it took us 15 years to start paying the same thing to principal as we were paying on interest. But on the 15-year loan, I mean, we're paying a little less to principal than we are to interest, but it's you basically start paying half and half from the beginning. So that's, you wind up saving a lot of money in the long run. Well, you wind up saving $100,000 in the long run. So the moral of the story is someday, whenever you want to buy a house, if you can live in one, I mean, it depends on how many kids and whatnot you have, but if you can find one that you can pay off in 15 years, you'll save yourself a whole lot of money than if you find one that you can pay off in 30 years. I mean, of course, your realtor, I mean, the first thing they're going to do is they're going to ask you, hey, how much money do you make? Because they're going to try to sell you the biggest thing you could ever possibly pay off, because the bigger house they sell you, the more money they make. So don't tell them, I mean, you need to be clear with your realtor. It's like, okay, I'm looking, don't tell them how much money you make. Tell them I'm looking for a house in this price range. I mean, you need to figure out beforehand, hey, what can I pay off in 15 years? Figure that out, and then tell this is the price range of the house I'm looking for. So let's do one more just while we're at it for the grins of it. So that's a house thing. Think that's funny? Now let's buy a car. You want to buy a car?
No,
How much are you going to pay for a car?
30,000.
30,000. All right, we're going to start with a $30,000 car. And cars right now are also pretty bad interest rates. Let's say you get this at 7%. And let's go 6 years to pay off the car. That's pretty typical. So you're going to have a 7% interest rate, making payments every month. You're doing payments every month for 6 years, and you're doing a $30,000 car. So you can have this car for $500 a month. Does that sound good?
Mm-hmm.
How much you think you're paying for the car in the long run? So times 12 times 6. Well, not too bad. You paid $36,000 for that car. Anyway. All right. Anyway. That's kind of how loans work. But, let's actually go back to the homework real quick. It's about that time. But let's do a couple of these and we may call it good for your day. All right. So goes back to doing investments or whatever. So I guess this is some guy wants to save up money for his kid's college. His wife just got pregnant. So it's like, hey, 19 years from now, I'm going to need $120,000. So he says, well, how much money does he need to put away at the end of each year? He wants to do that. Again, if you're doing investments, if you want to know what do you need to pay now, it's instead of the PMT, which is the house loans, it's PPMT. Let's make that smaller. I don't care which one, I just want one of them. I want one big enough so John read it. Okay. All right. So we're going to go PPMT. I'm going to go ahead and click that so that it'll remind me what all I need to put in there. So first of all, I'll put in the rate, 0.0425, and it's annually, so I don't need to divide by anything. All right. I need to put in the number of, well, sorry. This first per is always just where do you start, which is always 1. So that's stupid. I don't know why they make it in there. Number of periods is, well, 19 years, and we're only making one payment per year, so 19. And then what do we want to wind up with? Well, we want to wind up with $120,000. So to do that, I need to put $4,000 away every year. Need to. All right. And how am I going to figure out how much was interest and how much was me? Yeah. So this guy, no, I don't know why I'm doing that. So that times 19 is what I paid. So I paid in 80,000, and so 120 and that. So 39,000 came from interest. I'll do that. And I didn't realize I wanted both of them. I would have copied it too. Oh, apparently my round off is bad. Okay. So instead of that, let's replace it with the rounded off number. So 4232. Oh, oops. Change the plus to a minus. All right. So let's take that. It sure does not like me, does it? There we go. Well, they just changed by $5, right? So it's gonna go down by $5. Nope.
Take the dollar sign.
No, it takes the dollar sign. Oh. Sometimes you have difficulties with technology. All right. Point is, I got $40,000 by playing this when my wife got pregnant instead of waiting until my kid went to school. So, all right. Do one more and then we'll call it good. So we're going to have $120,000 in 16 years. And there we go. Okay. PPMT. My rate is 0.0525 and it is monthly. So I'm going to divide it by 12. I'm still starting on the first month. All right, number of months. Well, 16 years. Oops. 16 years times 12 payments every year. And at the end of the day, I want to have $120,000. So paying about $400 a month. So round up to the nearest dollar would be 401. And then what did we pay in? 401 every month for 16 years. So we paid in $76,000. And everything else was interest. Easy enough. So again, I mean, let me just kind of to prove a point. If you go to view an example, it looks horrible. So view an example will tell you how to do this by hand, but Excel will do the whole thing for you. So that's the way you want to go. All right, I guess we'll